Okay, folks, this next one, really cool. We want to solve logarithmic equations and exponential equations. And so what we need to do is we need to make work out of this 8 here. So it says 8 to the x is equal to 162, and we want to see what that is. Well, there's a special operation we can do, and it all comes down to this piece. If you remember earlier in your notes, we talked about this, that log base a of x, those cancel, leaving you with x. They are inverse operations. And a to the log base a of x, those cancel, leave you with x. So what we do to one side, we can do to the other. Now, a lot of people, when they get to this, they want to like divide both sides by 8. Well, that's not what you do. And you don't subtract 8 from both sides. What you can do is this. Take the log base 8 of both sides. Notice when we take the log base 8 of both sides, that's gone. And you have x is equal to the log base 8 of 162. Fortunately, we know how to calculate that. We do the log of 162 divided by the log of 8. Take my calculator. And I get 2.447. Again, we're going to write out to 3 decimal places. They actually suggest 6, but we'll just do that many. We have a base of e. I want to get rid of a base of e. So let's take the natural log of both sides. Those go away, leaving with x is equal to the natural log of 2. I have that button on my calculator. Natural log of 2. I get 0.693. Try another one here. We'll try d. 2 to the x is 85. I'll take the log base 2 of both sides. Notice those go away. I get x is equal to log base 2 of 85. I take the log of 85 and divide it by the log of 2. Whoop, look at that. I accidentally multiplied them. Second enter, and it brings back the same thing. And I can go ahead and insert a division sign. 6.409. It's good to have an idea of what you're looking for. Again, if you take 2 and raise it to the 0.5, which I came up with earlier, you can see you don't come up with anything near 85. But if you take 2 and you raise it to 6.409, you can see that you for sure do get about that 85 value. Now we'll try f. I want to get rid of e, so I take the natural log of both sides. Notice those go away. I get x is equal to, and fortunately for me, I have a natural log button on my calculator. I take the natural log, 85, 25, excuse me, and I get 3.219. Now it says solve the following exponential equation. So same type of thing, we just have a little bit more added on, okay? So we're going to go ahead, we'll pick a couple here, not all of them. We'll skip this guy here, and we'll skip this guy here. But I want to get at that x, so I'm going to take the natural log of both sides. Those go away, leaving me with 2x minus 3. And then I get the natural log of 7, which is 1.946. Now that I have that, go ahead and solve it by adding 3 and dividing by 2. 2.473. Looks like a lot going on here, but let's just be patient. We'll start by dividing by 2. We get 9 minus 12 raised to the 7 minus x is equal to negative 934 divided by 2 is negative 467. Now I'm going to subtract that 9 off both sides. So I still have that negative 12, 7 minus x is equal to negative 700 or 476. Get rid of the negative, and I have 12 raised to the 7 minus x is equal to 476. Now I want to get rid of the 12. So I take the log base 12 of both sides. Notice that these go away, leaving me with 7 minus x. And log base 12 of 476, that's easy. 476 divided by natural log of 12. Notice how sometimes I use log, sometimes I use natural log. Doesn't matter as long as you use the same one. You get 2.481. I'll subtract 7 and make it negative. X is 4.519. There's my solution. Look at letter D. Letter D is tough because in this situation we have two different bases. So sometimes people like to take the log base 3 of this side and then the log base 2 of that side. Well, you can't do that because with equations, you need to do the same thing to each side. So I just encourage people to just choose one. And a lot of times people say, I'll choose log base 3. Now, what's really nice about this is that the log base 3 and the 3 cancel, leaving you with the x plus 1. But what's not really nice about this is this guy. So we have to figure out some way of working that through. And there's no way of really dealing with the log base 3 of 2 right now and getting at the x. But what we can do is we can use our properties of exponents and drop that guy out front. 2x minus 3 times the log base 3 of 2. Isn't the log base 3 of 2 just a number? For example, if you take the log of 2 and divide it by the log of 3, you can see that you get 0.631. So we have x plus 1 is equal to 2x minus 3 times 0.631. Now we have a basic equation that we can solve. Distribute that 0.631 to both parts. X plus 1 is equal to 2 times 0.631. And I get 1.262. And then we have 3 times 0.631. And we get 1.893. Combine like terms. 2.893 is equal to 0.262x. Take the 2.893 and divide it by 0.262. And we get 11.042. There you have it. Last one, we'll try F. Most commonly, people just try to take the natural log of both sides, and they just start canceling e's off. Completely incorrect. You know, what if it was x squared minus 5x plus 4 equals 0? Couldn't you solve that by factoring? Well, it turns out in this situation, you could factor this as well. We have e to the x times e to the x is what gives you e to the 2x. It's a minus 4 and it's minus 1. So e to the x minus 4 is equal to 0, and e to the x minus 1 is equal to 0. So e to the x equal to 4, and e to the x is equal to 1. How do we get rid of e? Take the natural log of both sides. So x is the natural log of 4, and x is the natural log of 1, which you all know is 0. The natural log of 4, 1.386. So x is 1.386 and 0. Let's change this. Suppose that we don't have an exponential equation. Suppose that instead of an exponential equation, we have a logarithmic equation. Well, we are going to create a base on both sides. So notice this becomes 5 to the log base 5 of x is equal to 5 to the second. That's our inverse operation. These cancel, leaving with x is equal to, in this case, 25. Create a base of 8. And we get 3x minus 7 is equal to 64. Where 3x is equal to 71. X is 71 thirds. Try D. Subtract 4 from both sides. 3 log base 3 of x is equal to 6. Divide by 3 log base 3 of x is equal to 2. Create a base of 3. Gone. X is 9. What if it's something that involves natural log? No big deal. Subtract the 6. 2 natural log of x squared minus 2 is equal to 3. Divide by the 2. Natural log of x squared minus 2 is equal to 1.5. How do we get rid of the natural log? You create a base of e. And when you do that, you get x squared minus 2 is equal to e to the 1.5. Let's look at your calculator. If you click second natural log, you get e to the, and then 1.5, 4.482. Add that 2 over, x squared is equal to 6.482, and then square root. Plus or minus 2.545, or 6, excuse me. There you go. All right. Now, suppose we have a logarithmic equation. This should read like this. Notice that we have multiple logarithms. I would like to write them first as a single logarithm. So I could write this as the log of x over x plus 1 is equal to 2. I want to get rid of the logarithm. So I'll create a base of 10. Those are gone. X over x plus 1 is equal to 100. I solve that by cross multiplying. 100x plus 100 is equal to x. Or 100 is equal to negative 99x. Divide by negative 99, x is negative 100 over 99. Now, although that looks good, it turns out that that's not the answer. It turns out that in this situation, there is no solution. You might wonder why. Well, if you think of the graph of a logarithm, from your previous assignment, you all know that the graph of a logarithm looks like that. So that means that the domain is from 0 to infinity. Or in other words, no negatives, right? No negatives. Well, let's see what happens here. If you put in negative 100 over 99 into that, you end up taking the logarithm of a negative. And if you put it into here and add 1, it's still the logarithm of a negative. So in this situation, there is no solution. Let's look at the next one. Again, we will divide natural log of x plus 1 over x minus 1 is equal to 3. We will create a base of e in order to get rid of the natural log. I have x plus 1 over x minus 1 is equal to e cubed. What is e cubed? Second natural log, e to the third, and I get 20.086. We can now cross multiply. 20.086x minus 20.086 is equal to x plus 1. Subtract the x, we get 19.086x is equal to add the 20 to the other side, and you get 21.086. When you divide, you get x is equal to 21.086 divided by 19.086. We get 1.105. Let's think about that 1.105. If you plug it back in, it's a positive there, and it's also a positive there. So therefore, it does work. Two more. Now we have addition. So do the natural log of x plus 2 times x minus 2, or x squared minus 4, is equal to 2. Once I write it as a single logarithm, I then can create a base. A base of e, I have x squared minus 4 is equal to e squared, I get 7.389. X squared is equal to 11.389. Let's take the square root of that. 3.375. If we plug it in, we get a positive there, and we get a positive there, only if we use positive 3.75. So it's not the negative, it's just x is equal to positive 3.375. If we use the negative, we come up with a negative result. So this is our only solution. And the last one. First thing I'm going to do is I'm going to move this 2 up here. I have the log base 3 of 4x plus log base 3 of x squared is equal to 3. I can now use my addition to multiply. I have the log base 3 of 4x cubed is equal to 3. Now we're going to create a base of 3. Those are gone. 4x cubed is 27. Divide by 4. X cubed is 27 over 4. Let's cube root that to see what we get. Math, number 4 is cubed root. 27 divided by 4. 1.890. Okay, a little bit longer of a lesson, but thanks for enduring. Good luck, and hope to see you in a Google Meet, and we'll work on some things together. Good luck. See you soon.